We're now going to learn about intermolecular forces. These are the forces of attraction that hold molecules together so that they can form solids and liquids. All of the intermolecular forces between molecules are going to depend on the intramolecular forces, which determine the structure of the molecule. All of the physical properties of a substance are going to depend on the intermolecular forces. Intermolecular forces, or IMFs, are the attractive forces that hold one molecule to another molecule. They determine the physical properties of a substance, properties like boiling point, surface tension, vapor pressure, volatility. Ionic compounds have strong intermolecular forces. They are the electrostatic attractions of positive and negative ions. These compounds are hard, crystalline solids. Polar molecules that are covalently bonded have moderate intermolecular forces. These substances are usually liquids or soft solids. Let's see how polar molecules attract each other. The forces of attraction that we're going to talk about are not nearly as strong as the intramolecular forces that exist between the hydrogen and chlorine of each of these molecules, but they are fairly strong forces. Polar molecules would attract each other fairly strongly. They have a positive end and a negative end to each molecule. The positive end of one molecule is attracted to the negative end of another molecule. These are the intermolecular forces, or IMFs, and these are of moderate strength. The name of these intermolecular forces are dipole-dipole forces. These are the forces of attraction that exist between two polar molecules, and again, these are moderate IMFs. Here's a picture of a sample of polar molecules with all of the dipole interactions that take place. Hydrogen bonding is an especially strong dipole-dipole attraction between water molecules. Water, hydrogen fluoride, and ammonia are three very common compounds that can form hydrogen bonds. Again, hydrogen bonding is nothing more than a dipole-dipole attraction, but it's especially strong. The reason is that the hydrogen is covalently bonded to a very electronegative element, such as fluorine, oxygen, or nitrogen. The small size of hydrogen and the large electronegativity of NO and F create a very strong intermolecular force between one molecule and the other. The hydrogen bond is not as strong as the hydrogen-oxygen bond within the water molecule, but it is an extremely strong dipole-dipole interaction. The strong hydrogen bonds within water molecules give water a much higher boiling point than we would expect for such a small molecule. Nonpolar molecules have the weakest intermolecular forces of all. These substances are usually gases or volatile liquids or extremely low melting point solids. So how would nonpolar molecules attract each other at all? They do this by what's called an instantaneous and induced dipole, or London dispersion forces. A shift in the electron cloud of one molecule causes an instantaneous dipole, and this molecule then induces a dipole in an adjacent molecule. So a shift in the electron cloud causes an instantaneous positive-negative end to a nonpolar molecule. This molecule then induces a polarity in the molecule next to it. The opposite ends of each molecule will now be attracted to each other for a very short instant of time. Then all of the polarity will instantaneously go away and the process will start over again. An instantaneous dipole, an induced dipole, and an intermolecular attraction between the two molecules. These forces are very short-lived and not nearly as strong as the permanent dipoles in polar substances. Here's the range of the intermolecular forces again. Ionic are the strongest. Dipole-dipole exist in covalently bonded compounds that are polar. And your London dispersion are your weakest intermolecular forces. They exist in your covalently bonded compounds that are nonpolar. Polymers are giant molecules made by joining many small molecules called monomers together. Polymers make up many of our plastic compounds.